Hello and welcome to this route building tutorial. In this tutorial I will explain the basics of catenary. I will show you how to place it on different sections of the track, and I will also show you some different situations in which you may need to add catenary, such as junctions, turns and crossovers. So let's get into it. Obviously I'm going to start with the very basics, the straight track. A single straight track. Now, in real life you may notice that the catenary zigzags from left to right constantly. That is to make the wear on the pantograph equal, so that it doesn't deteriorate itself so fast. Now, how to represent that in the game? Well, obviously, first things first, you will need a good catenary set. Unfortunately, there are no American sets that I can think of which do this, which allow for zigzagging easily. And so you would have to take already big existing splines and try to maneuver them yourself, which might be easier for some of you, might be harder for some. It really depends. Now, generally working with catenary is a tedious work. It's easy once you understand the basics, but it takes a lot of time. It just takes very long to place catenary on some stretches of tracks. The more tracks you have, the longer it will take for you to move along. Alright? So for example, if you want to electrify big stations, you can easily spend an entire day on that, maybe even 2 days. Depends on how much free time you have. So, let's get into it. For this tutorial, I'm gonna be using the CZSK catenary set, which allows me to demonstrate everything, from single tracks to double track to gantries. So, let's start then with the short single track straight section. So I'm gonna find the catenary poles. Oh yeah, that's one more thing. I will be mostly just placing down poles. In certain situations I will also place down the wires, but just to save time I will be focusing mostly on the poles, and from that you will know where to place the actual wire. Now, a good catenary set will have poles and wires separately and poles and hangers separately. Now, what is a pole, what is a hanger, what is the wire? So let me then show you, I guess. I'm gonna use this one. So this is a pole, right? It's nice and simple, just what will be the main support for the catenary. Next up, we have the hangers. Now these guys will hold the wires. What are the wires? I'm gonna be using the KV set for that. Where is it? This one. And that's a wire. Probably harder to see, but yes. So you get it. Those are the three basic parts. Those are the pretty much three only parts that you should be using. Right? The pole as the main support, the hangers, and the wires. Now, for the hangers, you may see here that, oh, there are two kind of like extensions. One is shorter, one is longer. What is their difference? What are they? Well, when it comes to catenary and the zigzagging, there are three standardized letters which mark which position the wire is in. There's I, there's O, and there's C. Inner, outer, center. These guys are inner and outer. Now, how do you know which one is in, which one is out, and which one is center? The one closer to the pillar, the pillar, which is gonna be here, is the eye, the inner. The one further is O, the outer. The one in the middle is center, obviously. There's no middle in here, but you get the point. Okay. So how do we do this now? We've got the pylons, we've got the hangers, we know the definitions, alright? So now we just need to actually make the catenary. So let's get to that. Now, I'm gonna be using the CZSK one obviously needs to find the correct pylon that you want to work with. In my case, I'm gonna be using these ones, for example. So I'm gonna start with an inner pylon. Actually, no, that's a C, center. Gonna start PS. No, this one is. This one is an inner. So I'm gonna start it with that here. Now, the standardized length is different in each country, but most of them are available for distances of 30, 40, and 50 meters. Those are the three most common standard lengths, or like distances, a wire can span between two pylons. Some catenaries will allow you to go up to 70 meters, some will allow you to only 60 meters, some will allow only 50 meters. Alright, it's different for each and every set. If you want to keep realism, that is. If you don't want to keep realism, then it's up to you. So, we have an I pylon here, and I will also place an O pylon. Now, I have the added advantage here of the grid texture, so I know that these two pylons are 20 meters apart. I'm gonna put them 40 meters apart, like that, and I will start alternating them from now on. So I, O, and I. This will produce the zigzag. When you place the wire in here, it will go left, right, left, right. So now we have the zigzag, we have the alternating in it. That's the simplest thing. As a single track, straight track, very easy, very simple. How to put a wire on it, I feel like that should be explained as well. It's fairly simple and obvious. Some people may find it a bit difficult to understand where it has to connect up. Some will try to, do some other stuff like just place it all over the place. Now, where to put the wire? You see this little extension on the bottom. That's where the wire goes. So don't try to adjust the height of the wire and put it at the edge here, on the edge of the very hanger or somewhere on top of the hanger. You put it on the bottom, right there. Now, you just have to align it. And that's probably, well, not the hardest, but like the most tedious part of this job. Aligning the catenary. This is what takes time. Once you figure out the placement of the pylons, you just have to spend a lot of time actually making the wires. Now, I'm not saying that placing the pylons is easy and fast. No. I'm just saying that generally you're gonna be spending a lot more time placing down the actual wire and trying to make it, fit to the places it's supposed to fit. So this is a properly aligned catenary. Alright, on the hangers, correctly on both top and bottom. Now, some catenaries will be tilted. Now, what do I mean by it? Let's take the German catenary for example. I have the advantage with the German one that they already include pylons with their catenary, at least with the splines. You just need to know your assets. The German ones are called Flachmast, if you want the wire with pylon. If you want only the wire, it's Fahrdraht. And you can see the tilt here, how the wire just goes from left to right on the bottom, and on the top it goes from right to left. So switching sides. Now this is something that the German catenary does. Now each and every single catenary will have a different system that it works with. So it's important that you find the correct pylons, the correct wires to work with, so that you literally have a complete set of catenary available for use. Currently, the most complete ones I can think of are the Czechoslovak catenary on the DLS and the German catenary on the DLS. There's also the British catenary from Mark 1 to Mark 3, which is also good quality, and I believe it's also a complete set. I haven't really played around with it. But those are the 3 catenary sets that are fully complete. Now obviously also the Russian catenary set, but good luck figuring that one out. It's not like it's harder, there's just more to it. Alright? So, now we have the basics, we have the single track done. What is the next thing that we have to do? I'm gonna load up the TRS19 again. And we're moving on the straight track but double track. And I'm gonna start with placing an O type on here. Now you want a double track, right? So you may be thinking, oh, I can just do this. Yes, that's a possibility. You can do centered catenary like this. Though usually you wouldn't do it with both an O on each side. You would do it as O and I. May look a bit weird, but this is how you would do it in real life as well. For the alternating to still be there, and to be in kind of like offset. So one side is O, the other is I, so that the wires move from left to right together. There's obviously some real world reasons why, and I'm not gonna be digging into that. Now, center catenary pole, alright, you can do it, but it's mostly used for trams, maybe light rail. Definitely used in on normal railways, mainly in Germany, in stations, but not really used outside of the station. So, well, you may see these while you have platforms on both sides, so as to not obstruct the platforms that would be there. You just have it centered. But outside of stations, you generally see this kind of configuration. An O on there and I on there to keep the alternating in there. Now, how would you go about this? Obviously the same as the single track, just mirrored, kind of. So let's see here, 40 meters away from here, I'm gonna place an O on this side and I on this side, okay? This alternates from here, from the right side of the track, the wire will go to the left side of the track, and now it has to move back to the right side of the track. That's the alternating done on a double track line. Alright? Simple as that. Not gonna be placing a wire here, you know the basics of where to actually put it. Now to the third step, I'm gonna be moving to 3 track sections. Now usually at this point you want to switch to gantries. So how do you do a gantry? Now, in this set, like generally what you should try to accomplish is to have a gantry spanning all the tracks. Now this you use for all the tracks from now on. If you have more than 3 tracks, you just gantry them. There's no like exceptions. Maybe there are that I'm unaware of. Different country, different system, different method, you know it. But usually if you have more than 3 tracks next to each other like this, you just go with bigger and bigger gantries. Alright, my current system allows me to go up to 6 tracks per gantry. I'm gonna show it on the 3 track, because as I mentioned before, the more tracks you have, the longer it will take for you to make the catenary on them. So I'm not gonna be wasting time with that over here. So gonna move 40 meters away again, place another gantry here, and another 40 meters again, place a gantry there. Alright. So you may notice that, okay, we have the gantry, but there's no hangers, right? Now in this set, it's a separate asset. The hanger is a separate asset now. When you have a gantry that has a separate asset for the hangers, you've pretty much won the lottery. Because this will allow you to adjust it as you need. Alright? So you might end up with stuff where you need the catenary to be, you know, like it is right now, for example. Left side on there, right side on there, and left side on there again. Right? Alternating like that, or maybe like this, or maybe like that. You know, the possibilities are now endless as to like, well, not endless, but like, there's a lot more to them according to what you need. Instead of having a fixed gantry with fixed hangers, so that all of them point in the same direction, you are not limited if you have them as separate assets. Alright. So how would you go about the gantry here? Now, it's fairly simple. You keep all the tracks on the same side. All the wires on the same side, right? So while the previous one was on the left, this one is going to be on the right. You align the hangers with the gantry. You can see we're moving from the left to the right, and we'll be moving to the left again. Simple as that. Alright? Just align them and then put the wire through there. Just like that. Left, right, left, right. Left, right, left, right. And left, right, left, right. Now, turns. This is something that will need a bit more explanation now. Because we know the basics. Okay, so I has to have, you know, is this kind of stuff mixed with O. But what does it really mean? Why does it work like this? Well, you see this little thing on the bottom that holds the wire. I'm gonna call it a pulley or puller, for example. Just, you know, or holder. You know, it doesn't really need a proper name. Simply, it holds the bottom wire. Now, what it has to do is pull on that wire. It cannot push or it will break off. These things are designed to pull the wire, not push. Okay? So, that's why you cannot, for example, do... Let me do this. Oh. Thank you, game. Appreciate your input. That's why, for example, doing this... Oh no, sorry. If we were to switch it around completely, as in these guys were like this, and these guys were coming in like this... I'm stupid. I'm trying to get demonstrate. This will work. This will work now. Right? Like this. So they're no longer pulling the wire. They're pushing it. Just from the trajectory. This would be pulling. This would be pushing. Alright? So you want to make sure that they always pull the wire. Okay? That's the main importance on this all. That's why you need to keep the zigzagging. That's why you need to keep, the symmetry in this all, so that the wire keeps on pulling, not pushing. And that leads us to the turns. Now that we know they have to pull, obviously we have to make sure that they do that through the entire turn, right? So we're gonna be using eyes on this. Just like that. This will ensure that the wire is always being pulled. If it was like this, we would end up with the wire being pushed and outside of the turn radius. Now, what about the turn radius? You see, a train has a pantograph, but that pantograph is only of a certain width, right? You cannot really make it go outside of the pantograph area, or like the area the pantograph is able to catch, because how would that work? That the train would just lose power. So you need to make sure that the wire is always situated above the track, above where the pantograph is. Now most trains, at least for the European stuff in the game, they have a pantograph that is the width of the rails. So if you keep the wire, at least if you're making a European route, if you keep the wire between the two rails, you're safe. Alright? The moment you have a wire that has to leave that space, just for an example like this, that's not good. The train will no longer be able to catch the wire, the power will go out. Alright? So make sure that the wire is kept above the track between the rails. Just like that. On the entire turn. Now, how would you go about a double track turn like this? Simple. As the previous one, you just need to make sure that one side is I, like that, and the other side is O. Right? So these one will pull on the wire this way, and these ones will pull on the wire this way as well. Now you can offset them over here, so that the inner turn has smaller radius than the outer turn, so you can offset the pylons like this, but that's generally not recommended. Not only does it look weird, you may also lose the symmetricality later on when you reach the next straight section and will have to regain it again somehow. Otherwise, it can cause problems later on when you get to junctions and stuff. So try and keep the poles like this aligned next to each other. Alright? Simple as that. So now for a 3-track turn, once again, recommended gantries. Well, you can obviously use the normal pylons as well, but it's always nicer to use gantries when you have more tracks. So once again, place them down like that. You can span them around. Now I have the advantage of the grid on the straight tracks, but over here I don't really, because it's a turn. So you may want to use the rulers and measure out, oh, there's only 30 meters, right? So let me move it to 40 meters, which is around here. It's not exactly on the yellow line because of the turn. So boom, 40 meters like that. I'm not gonna be bothering with setting the proper length for all of them, but just so you know, you can use the ruler to measure out the distance between them if you don't have the advantage of the grid. Now, One thing with these assets is that if you quickly need to grab something from the set, but you cannot get to it because there's another asset. For example, I want to grab the holder, but I cannot get to it. I want to grab the support, but I cannot get to it because of the gantry. So delete the gantry, use the get object function, select the hanger, and then just Control Z, and nothing will be changed there, and you will have your wonderful little hanger in hand. Oh, was a double click from my mouse, thank you. Now for the turns, obviously, once again, just like the previous, they need to pull on the wire. No push, pull, right? So once again, the holder has to go from this side, like that. Right, so remember, not this side, this side. Like that. Align them once again. Make sure that the wire will always be above the tracks as well when you are doing this. Now, when you get a good eye on the catenary, then you will pretty much be able to already just place down the gantries, their hangers, the pylons, space them out appropriately, or according to the ruler, to the length, and you will still know that, okay, yeah, this is good. I can still put the wire in without it being any conflict, right? When you are new to this, I recommend, doing this at the same time. So you place pylon, then place another pylon, and then you drag the wire between them. All right, and then you adjust accordingly. So something like that. Now we've gone through the straight tracks, through the turns. Let's get to a bit of a more complex stuff now. Junctions, for example. All right. Now the way you do junctions is a bit different, because obviously you need to have a wire that goes left, and you need a wire that goes straight on, or maybe right if you have a wide junction. So how would you do this? Now, someone who doesn't understand anything about this will simply say, oh, I can just, put the I in here. That's not what I wanted. Take the I hanger, this one. Someone who doesn't understand this or just is new to this would say, oh, I can just use this and then just, slap the wires on like that, right? Something like this. No. This is not how you do it, all right? The way that you make the wires on a junction is a bit more complicated, because the wire cannot just split off. No, it has to start and end somewhere. So in my case, I'm gonna be using where is this? I'm gonna get in there. Pt.1, this one. Like this, align it kind of, at least somewhat. Right, and now I'm gonna use this. Okay, so we have this. Now you once again might be thinking, okay, so that's how I do that, but where do I start the pylon? Do I just, place one here and just merge them here? No. What you have to do here is figure out your surroundings a little bit. So for example, you have an incoming wire already, right? Let's say this is incoming with I, and you have an O in between. All right, and then you hit the junction, okay? So how would I go about this? Well, I, O, I. And from I on here, you have to continue turning. So you will be branching off. If it was the other way around, so if this was O, if this was I, then here you would use O, and you would continue straight on. So for this, what I have here, I have IOI, so I'm gonna be branching the wire from here off to the left there. But where does the wire that will go straight then come in? So obviously starts with an O here. So the easiest thing you can do right now is, instead of this O here, you can take one of the, oh, I'm not gonna be doing it. I'm gonna use ones that already have the hanger attached. So this is I, which means I'm gonna use a BPO in here. Oh, that's only the support. I'm sorry about that. BPO without the S. Come on. This one, for example, right? So IOI. Now, why specifically this one? Well, since I'm using this set, I'm trying to keep it realistic to this set, and the wires for this set should start and end on this type of pylon. So, how does a wire actually start then? Well, let's go through this all together completely, right? Including the wires. So we have an incoming from here. Got from I to O. Excuse me. Like that. And from O, we go to the I in here. Alright? And obviously from here, from this I, we will either place I's here, which wouldn't really be good, considering that the next I, in order to keep the wire above tracks, would clip with this track and possibly the trains. So you should here use an O. I'm just gonna quickly grab this one and move it into place like this. Alright? And then use an I over here. Like that. And from here, obviously, since we have the wire at I, we will go to this O, keeping the wire above the track between the rails. You can see it's just about. So if we were to do it the other way with the pylon on this side, you can see that wouldn't really work out. So stuff like this happens. You may have different approach to this with different turns, so you may even be able to go for this side, but due to the circumstances that I have here, you can only do this. Now, the other wire has to have a start, so let's give it a start. Oh, that's not what I wanted. No. This one. That's the one. So, I'm gonna place it like this. So this is a tensioner. That's how I'm gonna call it. It's a device that makes the catenary be tensioned up. The wires are heavy. You know, if they were just held up in place like that, they would fall. So they need to be tensioned up so that they hold in the place they're supposed to hold at. In this case, I'm gonna have to align them to the pylon properly. Now I recommend with this to start aligning with this side that you want to enter the tracks. And we want this to enter O. So we just align it to O there. Hold on, this is the wrong one. This is the U. I need the N, no, the C, this one. Like this. There's one more catenary type that I didn't mention, or actually two more. There is U and there is T. T is for tunnel and U is for Uber, which is not the taxi service, but the German word for above. At least from my understanding for the catenary sets. That's a TB. God damn it. You can see there are a lot of different endings for a lot of different pylons, And if you're not paying attention, you will end up confused like I just did. Right, so this is the correct one. Obviously align it properly, and boom. You have the start of your catenary. Approaches in, like this, and from here, you need to make it go to I. This way, you pretty much made sure that it is being pulled, not pushed. Right? So remember, wire has to be pulled, not pushed. That's the most important when it comes to this. Alright? And you can cross them over as much as you want at this point. Right? There's not really like any... what's it called? There's not really like a set rule as to what should be like when it comes to like the crossovers of the wires. Obviously different systems might have different approaches to this. For example, the 3000 volt DC system pretty much requires insulators on these crossovers. But that's additional stuff that I will talk about later. Now, that was the basic junction here. I'm not gonna be doing the wires again for the next junction, but because you already like get the point from this one. So you have pylon, you're gonna have the I/O holders like this on it, right? And accordingly to that, you will make the catenary. So start with O over here. Gonna bring in an I, for example, here. Now, how would you go from this point on? Now, you need to understand how you want to make the catenary. How you want to make the catenary, right? So we'll have I to O to I, okay? And from here we'll be starting to this O. So this O has to go straight to make sure that it's being pulled. So as a result, there's going to be an I over there. Now, however, we have an I over here, but we need to, you know, the tracks are going to be parallel to each other. So putting an O anywhere in here is a no. You put an I in here. Alright? Now this side will go to O, and this side will remain on I. So, now if you were to follow the wires, the ones coming from here, I, O, I, I. Because of the turn, all of these I's, these three I's together, will be pulling the wire. None of these will be pushing the wire. Because of the position and the turn, you know, it will be only pulling on the wire. And the one starting from here will go to O, to I, to O. And you will end up with an alternating in the end. Right? Simple as that. So you may end up, and you should end up with two I's aligned like this, and like three I's, like, you know, right behind each other. That's like the best way to approach this. Now, here's the other stuff. So crossovers, yard leaders, and in the end, there's gonna be a addition to the catenary as a whole. So I'm gonna keep that for the next episode, just to keep this at like 40 minutes each, hopefully, maybe even less. Because you can see we've only gone through 3 things and it's already been 40 minutes. So I'll explain this and the rest in the next episode. Alright? So thank you, and hope you learned how to do at least the basics for the catenary. See you next time.